Hey physicists, for this activity, we are going to be doing a hallway resistance activity. I'm sorry that you can't be in the building to do this, whether you are virtual or absent or what is keeping you from here. But what is we hang up resistors around the halls. So my room and Mr. Clamo's room are right here, and that's going to be the battery of our circuit. And then we have hung around the walls in the hallway out these various resistors so that students are going out and finding those to begin with. And then once they find those, they're coming back in and drawing this picture. So they would complete this drawing that would look something like that. And maybe they would do like, okay, so here it is. Here's my battery. I have a resistor here. Come down and come over here to a resistor. Come over here to a resistor. There is a resistor here. Come down, come over, come up, hit a resistor, up, and then branch off of that for a resistor here. So they're going to literally draw that circuit diagram. Now, remember that what's very, very crucial and very, very key in all of these is that you draw pictures. Every time you collapse a set of resistors, you need to draw a new picture to represent what those new resistors are going to be. So for instance, I would look at these guys and say, hey, aren't these two resistors in series with each other? So I'm going to walk you through the beginning part of this. This is really my R6 that is a 4 ohm resistor and my R5 that is a 2 ohm resistor. So if I redraw this, here is this top one coming down. Now I'm going to replace both of these with one resistor that is equivalent to the two of them in series together. And if you remember correctly, in series, we would add our resistances. So 4 plus 2 means I would replace it with a 6 ohm resistor, and that's going to be R56. R56. And I'm coming over here, draw this part. Now, I could also look and at the same time collapse this on this side of the circuit. So this is R1, it has 5 ohms. And this is R2, it has 10 ohms. And I would combine those into one resistor. And what is the value of that one resistor going to be? So I want to say, well, what is R12 if I were to replace that? And remember that in a parallel set of resistors, we would inverse add them. So I'm going to say that 1 over R12 is 1 over 5 plus 1 over 10. And whenever I do that in my calculator, so 5 inverse plus 10 inverse, and then flip my answer one last time to get R12, then I get a value of R12 that is 3.33 ohms. Okay, so now I have that one. I still have this value here. I know that it is the 3 ohm resistor. I still know this one is going to be the 8 ohms, and I still know that this one is going to be 15 ohms. And again, I would bring this back up, connect it to my battery, come around, and there is that one. So I've just collapsed two sets of the resistors, the 4 and the 2, and I collapsed the 10 and the 15. So these were in parallel, these were in series. Now the next thing I will look at is I can look at this and say, hey, aren't these two in series? But wait a minute, they're also kind of in series with this, and they're in series with this. So maybe what if we do this next? These two are in parallel. So if I take those two that are in parallel and I put them together, so if I come across and down to my battery, come down here, here's my 15 ohm resistor. Now I'm going to replace these two. So this was 5, 6, and this is 4. This is going to become R4, 5, 6. What is that going to be? So remember that I'm going to have in a parallel, it's got to be 1 over 6 plus 1 over 8 is equal to 1 over R4, 5, 6. And whenever you do that in your calculator, you should get 3.429 ohms for that. And then come across, here is the 3 ohm one that I have here. Come up here, here is the 3.33 ohm one that I have there. And notice that I'm getting really, really close to the end. So now, can't I take and collapse this one last time where all 4 of these are in series? And I'm going to have my battery come out, come down, and have a resistor that I could either label as RT or I could label it as R1, 2, 3, 4, 5, 6. But either way, remember that in series, all we do is we add those up, and when we add those up, we get 24.8 ohms, and that's going to be our total resistance. So I would not, in our learning management system Buzz, I would not put any numbers into Buzz until we get all the way done with it. but that is the beginning of how we would start breaking this down. Now, you're going to want to watch the video that we did that was on the collapsing and uncollapsing resistors. It's in the middle school project, the middle school assignment, which is, I think, called maybe circuit sample problems. If you're catching that, because the next thing you're going to do then is once you go into the learning management system, you have a total voltage off of the battery here. It's going to randomly generate a battery for you, rather 3, 6, 9, 12, 24, 120, some power supply here. And using that number that it gives you, can't you calculate what the total current is? So V equals IR. Then the next step is to unpack your resistors and to work your way backwards. And that's why it's so crucial that you have all of these pictures, because now I can look at that picture and say, hey, there is a I456 for this and a V456 for this and an what was this one? Number 7, I7 and a V7. And this one is going to have an I3 and a V3, and this one is going to have an I12 and a V12. And remember, if I'm unpacking into a series circuit, we would say SCC, or series current constant, so that whatever this current is, it's got to be the current for all 4 of those resistors, and then you can find the voltage. Then we're going to unpack that into this guy, and then we'll unpack this into this guy, and eventually that's how you get all of the things that you need in order to write into the problem. So I hope that gives you a start on how to do it. I wish I were here with you in person, but what you could do is you could jump on the Zoom link, you could send me an email, and we'll walk through maybe how or where you're mixed up on that for that. That gives you a beginning, though, of the hallway resistance activity lab.